Hi folks, this is number 3 from page 451. So they give us the equation of two lines and they tell us that these lines intersect at 5, 3 and they want us to find the angle between the lines. So the fact that they intersect at 5, 3 in particular is not going to really come into play here. I suppose they're telling us that they intersect, so they're indicating that these lines are not parallel or coincident, although we would have known that by looking at the direction vectors, which themselves are not parallel. So remember that if I have two lines, 2D here, that intersect, we look for the acute angle between them. And finding that angle is equivalent to finding the angle between the two direction vectors. So in this case here, we would get the angle that we're looking for if we happen to have direction vectors which gave us the obtuse angle between the two lines. We would just subtract from 180 to find the answer we want. All right, so we're going to find the angle between these two direction vectors by using the dot product. That'll be the quickest way. So we have -4, 7 dotted with 2, 1. Okay, so on the left-hand side, we're going to use the algebraic definition, and then on the right-hand side, we're going to use the geometric definition. Okay, so dot product is defined as the magnitude of the first vector. So here we have -4 squared is 16 plus 7 squared is 49 times the magnitude of the second vector here. So 2 squared is 4 plus 1 squared is 1 times the cosine of the angle between them. And so this is the only unknown left in my equation, so I can solve for it. All right, so let's see what we have here. We have -8 plus 7. So that's -1 equals, this is 49, 59, 63, square root of 63 times square root of 5 times cosine of theta. So let's find theta here. Get our calculator out. So let's see what we have. We have cos inverse of -1 divided by the square root of, and here we can just multiply these, so 63 times 5. All right, and so here we end up with 93.23 degrees, but this is an obtuse angle. So we're going to subtract this from 180 to get the acute angle. So here we have 86.77. Excuse me. So the angle that we're looking for is just equal to 180 minus 93.23, which we just saw was 86.77 degrees. Okay, and there's our answer. So just to recap here, finding the angle between two lines is equivalent to finding the angle between their direction vectors, which we did using the dot product. But because our answer was an obtuse angle, so we would have gotten this angle here, we just subtract from 180 to get the acute angle, which is by convention the angle between two vectors. Okay, that's it for this one.